This is Mrs. Thompson, and today we will be talking about the inverse trigonometric functions. More precisely, our objectives today are to understand and find the exact and approximate values of the inverse sine, inverse cosine, and inverse trig functions. We will begin with the sine function and then look at a few examples for the other functions. The procedure remains the same regardless of the trig function. The inverse sine function, denoted as y equals the sine inverse of x, notice what looks like an exponent of -1 is not an exponent. It is read as the word inverse. The inverse of a trig function also has another symbol, and it is the prefix arc. So the arc sine of x is another way of denoting the inverse sine of x. Regardless, it is asking for the angle or angles with the specified sine value. So, when you are finding the inverse, your answer is an angle measurement. If you're not finding the inverse, if you do not see the inverse symbol, if you're just, for example, finding the plain old sine, then your answer is the sine of the angle. In other words, it is the y coordinate of where that angle intersects the unit circle. And we've covered that before in detail. Looking at an example, determine the exact value of sine inverse 1 on the given interval. Our interval is from -π/2 to π/2. We have brackets for our interval, so that means these two values are included in the interval. So this is asking us what angle has a sine of 1. There's only one angle with a sine of 1 and on this interval, and that angle is π/2, 90 degrees. So that is our answer. We use a calculator to find approximate values. Exact values, like in the previous problem, those are found using the knowledge you have. So when you're asked to find an exact value, almost always that answer is going to be one of those common angles around the unit circle that you're responsible for knowing the sine, cosine, and sine of. Calculators again are used to approximate the value of inverse trig functions. On most calculators, the inverse sine or inverse trig function is the second operation of that function. So on most calculators, the inverse sine is the second operation of the sine key. Sometimes you'll be asked to write your answers in radians. That's popular in higher math courses. Sometimes you will be asked to write your answer in degrees. Make sure your calculator is in the right mode, be it radian or degrees. On most calculators, you may use the DRG key to convert your answers from radian, R stand for radian, to D, which stands for degrees, or vice versa. On other calculators, it has become quite popular to have to press the mode key to go and convert from radian to degrees and vice versa. There are many scientific and graphing calculators out there, so some of you may need to refer to your owner's manual and follow the directions for your particular calculator. In your calculator, if you enter the sine inverse, so second operational key, then press your sine key, enter the value of the angle -1/4 and press enter, you will get a decimal approximation, a nice decimal approximation, And when rounded to 2 places behind that decimal, that answer will be negative 0.25, negative 25 hundredths. A few calculators you have to enter the negative 1 for first, and then the second function followed by the sign button. So see what your calculator requires to get this correct answer. This answer is in radian. Same pattern, same thing for cosine as for sine. So the inverse cosine function is denoted as the cosine inverse of x, or arc cosine x. It is asking for the angles or angles with the specified cosine value. This PowerPoint does include graphs of the possible inverse sine function values. That is extra information. Example, determine the exact value of cosine inverse negative square root of 2 over 2. When you enter that in your calculator, you should get an answer. Actually, this is an exact value. My apologies. So do not enter it in your calculator. You should know this one. Square root of 2 over 2 for cosine, that is pi by 4, but that's the reference angle. We need to go to the quadrant where it's negative, and that will be when we arrive at a value of 3 pi by 4. So the only angle within the interval 0 to pi, including 0 and pi, with a cosine of negative square root of 2 over 2 is 3 pi by 4, making that our answer. Now approximating using a calculator. Use a calculator to approximate each value using radian measures, or state the value does not exist. So if you enter in your calculator cosine negative 1 of 2.5, your calculator will give you an answer of does not exist, and that is your final answer. Some calculators will give weird results that would probably appear weird to you. So if you get a result when you enter this in your calculator of something like the word error, or an abbreviation for the word error, maybe even the infinity symbol, that means you have asked your calculator to give you an answer for something that does not exist, and it is confused, and it is trying to tell you it does not exist, which is what you should write for your final answer. More practice. Again, we're still in radian units. So for additional practice, second function, cosine button, 0.25, enter, you should get an answer of 1 and 318 thousandths. Most of the time in my math lab, you are asked to round to to 3 places behind the decimal, the nearest thousand, and that is modeled here. Graph of the inverse cosine function. Again, this is just additional information, not required. The inverse tangent function, denoted as tan inverse x or arc tangent x, is asking for the angles or angles with the specified tangent value. Recall that the tangent function is defined as the sine function divided by the cosine function. So, to evaluate the arc tangent, this will require some division on your part. Example, determine the exact value of the tan inverse of negative square root of 3 on the interval from negative pi by 2 to pi by 2, and those values are included. So, that means this is you are asked for, let me back up, you are asked to find the exact value. So this means this is a problem that you should calculate based on the knowledge you have in your head. Those common sine and cosine that you should know for those common angles. So You have to find definition of tangent, again, sine over cosine. So for those common angles, dividing the sine by the cosine until you find one that gives an answer of negative square root of 3. And the one that will do that for you is the angle negative pi by 3. So that is the final answer. Approximating inverse tan expressions is done using a calculator like with the previous trig functions. So on most calculators, the inverse tangent is the second function of the tangent key. Again, make sure you're in the right units, be it radian or degrees. Again, these examples are in radian units. So just practice typing these in your calculator so that you know how to use your particular calculator to come up with the right answer. When you enter the tan inverse of 10 with your calculator in radian units, you should get an answer 1 and 471 thousandths. Likewise, when you enter the tan inverse of 0.25, you should get an answer of 245 thousandths. And this particular lesson concludes with a graph also of the inverse tangent function. Again, the graphs are optional. You're not required to learn the graphs.